In this video, we're going to go through a full example of graphing a rational function. This one is a little bit complicated, so we're going to do it one step at a time here. I've labeled them A, B, C, D, and so on. I will say that a lot of these steps can be done in any order, so it doesn't really matter which one you do first and so on, but we'll just stick with the ordering that I've chosen here for now. Okay, so first things first, we're going to find the domain. Now the domain, you only care about the bottom. If you take the bottom, set it equal to 0, you go ahead and factor this. And you're going to get 3 values of x, and these are all values that x cannot be. So the domain is x cannot be 0, -2, or +2. Now for part B, we need vertical asymptotes. And remember, you look at the bottom, but you also ask yourself whether something would cancel. And if it does cancel, then it's not a vertical asymptote. The numerator is already factored for us, and we see x minus 2 does cancel, which means x equal to 2 will not be a vertical asymptote, which means the other ones, x equals 0 and x equals -2, those will be vertical asymptotes here. For part C, it's any holes. Well, again, holes happen when something cancels, and we saw that it canceled x minus 2. Right, that's what canceled, set it equal to 0. That's where I get the x equal to 2 for the hole. Going for D, for X-Intercepts. X-Intercepts, you take the top and set it equal to 0. However, I do want to point out that if something cancels, it's not going to be an X-intercept. We already saw that part's going to cancel, so we're good there. The only other thing then is the x plus 5 squared, which means x plus 5 is 0, so x is -5. And I will go ahead and put down here that this has a multiplicity 2, or multiplicity here. That's going to be important in our graph. Then we need Y-intercepts. Let's see what happens if I plug in 0. On top I'd have 0 minus 2, 0 plus 5 squared over 0 minus 0. Well, that's something over 0 that's undefined, which means there is no Y-intercept in this particular problem. And then horizontal asymptotes. We need to know what the degree of the top and bottom are. Well, the bottom is already multiplied out, so therefore it's 3 there. The top, you got an x squared, and an x is going to be also 3. So in this case, they're equal. So my horizontal asymptote is going to be the leading coefficients, which in this case is 1 over 1. So my horizontal asymptote is y equal to 1. Now we have to take all of that and draw ourselves a graph. Okay, so we have vertical asymptotes at 0 and then at -2. Now I actually want to go ahead and make each one of these a half, so this would be -1 for 2 steps and -2. So that is my second vertical asymptote. I'm going to have a hole at 2, but holes are always the very last thing you deal with on the actual graph. I do have a x-intercept at -5, so -2, -3, -4, -5, and then so we get a little point right there. Then we don't have any y-intercepts, so we can't do anything there. Then we do have a horizontal asymptote at 1, so I use 2 here, so that means this is going to be at 1. Now, little side note, it's not super important what colors you choose, but there is a reason for why I'm doing it with this way, and that's because if you have a vertical asymptote, that's the red ones, there is absolutely no way to cross that. You cannot cross a vertical asymptote. Red means stop, right? However, it is possible to cross a horizontal asymptote. That's why I use green there, right? Green go or pass, red is stop. Again, not that important, but that's what we have. Now, the last thing is that normally we would have an X-intercept that we could, or sorry, Y-intercept that we could then start connecting dots here, but we don't. And we need something else to start here, so we need to plug in some number somewhere. I'm going to choose to plug in 1 just because I like it. So I would have 1 minus 2 times 1 plus 5 squared over 1 cubed minus 4 times 1. That's going to be negative 1 times 36 over negative 3 is going to be positive 12. So it's getting really high up here. So this is going to be up here at 1 comma 12. And I claim that this 1 point is going to be enough to draw the whole graph. I will say, though, that when you're starting these, you probably need more than 1 point, in which case you would plug in some more numbers here. But first things first, I know that I'm at this point, and always when you go all the way to the right, you're going to go towards the horizontal asymptote. And then you also know you're going to go towards the vertical asymptote. Now I could go up towards the vertical asymptote, or I could go down. However, if I were to go down here, let me use purple for this. If I had actually gone down on this, notice that I would have had to cross the x-axis here, and the only place you can cross the x-axis is at an x-intercept, and the only x-intercept we have is over there at negative 5. So all that reasoning tells me I have to go up towards the vertical asymptote there. But as I said, until you get the hang of that, you probably want to try a couple different numbers there and get a better idea of what the shape is going to be. Then, I'm going to now use something that I've never mentioned before. And again, it's something that you don't have to know. You could just plug in another number here. But I think it's a really useful thing if you do know it. So when I found my vertical asymptotes, I did not say anything about multiplicities, but I could actually find them. And you look back to where we got them from factoring here. All of our multiplicities were 1s. And it turns out if you have an odd multiplicity and your graph goes up on one side of the vertical asymptote, it's guaranteed to go down on the other side of the vertical asymptote. Whereas if your multiplicity had been an even number, then both sides either go up or both sides go down. So by knowing that, I know if one side goes up here, the other side goes down. Then I know that in the middle here, I don't worry about the green line. The green line is only for far right and far left. However, I cannot cross the x-axis because, again, the only place you can cross the x-axis is the x-intercept, which means I have to stay completely below it, which means I have to go down on the other vertical asymptote as well. Has to be down. Then, since the multiplicity is odd for that one, and I went down on one side, it means the other side had to go up. If I want to really continue on there like the other side did. And then I'm going to come over here, and I have to get to the x-intercept. But then I want to point out something. This has a multiplicity of 2 here, which means we do not cross, we turn around. And you turn around and go towards the horizontal asymptote. And this mess right here would be the rough graph that we're looking for. So again, take some time, try to absorb all the things going on here. I will say, when I normally give a problem like this, maybe it's worth 20 points or something like that, and the vast majority of that is going to be in all these A through F up here, all these individual sub-steps. Usually the final graph is only worth a couple of points. So to me, the actual final graph is not the important part of the problem. It's actually finding all the individual pieces, using algebra here. Because the final graph, I mean, again, you probably are not super impressed with my drawing skills here. You will likely do a better job than I have, but even then, if you want really accurate graphs, you need a computer for that, or a calculator. But regardless, these are the steps here.